Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel tanmoyChem. Today's topic of discussion is one MCQ. The question is in front of you. I request you please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried. Let's start. Now, question is for ester to alcohol conversion. So here ester, this is alcohol. Which of the below mentioned reagent result maximum reactivity? So this is actually asking which one is actually best reagent for this conversion. Okay, so four options are provided. By the way, student, let's learn this process a little bit better. So if you look at this carbon, its oxidation state is +3. 3 oxygen carbon attached and there is carbon-carbon bond which is not counted. Now if you look at here, there are 2 hydrogens. So actually here the oxidation state of this carbon is -1. Because hydrogen is more electronegative than carbon, so -1. Or if you think you want to calculate, let's consider this oxidation state of this carbon X. So it's attached to 2 hydrogen which is slightly more electropositive with carbon, so that's why 2 multiplied by +1. It is attached with oxygen with a single bond, so here you can write 1 into -1 and overall molecule charge is 0, so 0. So here you can understand X plus 2 minus 1 is equal to 0. X plus 1 is equal to 0, so X is equal to -1. So from there I can write the oxidation state of this alcohol's carbon atom is -1. Now, so this is, now if you look at reagents, it is sodium hydride. Sodium hydride means sodium plus hydride minus. Remember students, sodium hydride is not a good nucleophile. Actually this is a nucleophilic, you may consider reduction, means this reagent attacks and reduces it. Or more specifically, if I say hydride, I mean H minus, it is excess electron containing molecule, so it attacks, it opens up, in this reaction starts and it goes. But this sodium hydride's hydrogen is not that much reactive because one property, it doesn't have any directional property. What do I mean? So the hydrogen keeps this 2 electron on its s orbital, 1s orbital. So it's spherically symmetrical, not that much. But if you look at the second example, this is also hydride. First one is simple sodium hydride, second one is sodium borohydride, NaBH4. So in this case, if you look at the structure, this boron is actually surrounded by 4 hydrogen tetrahedrally, means sp3 hybridized. So if you say, so here sp3 hybridized, formal charge is on boron, so negative charge. And if you look at the polarity, so this is slightly negative character, so this is a weakly negative, so you may consider this is also hydride but not that much. So sodium hydroxide, sodium borohydride is, you can consider it's a milder hydride. Next, lithium aluminum hydride. Student, this is very unique. Similar like tetrahedral structure, lithium is tetrahedrally surrounded by 4 hydrogen here, and the formal negative charge is negative on aluminium, and this is also sp3 hybridized, but it has a unique thing. The difference of electronegativity between aluminium hydrogen is more compared to boron hydrogen. So these hydride, you can consider this is the more polar. So more polar hydride, so you can say this is more reactive hydride. Now if you look at the next one, palladium hydrogen. So if you react with palladium plus hydrogen, what happened? These hydrogen and palladium react together and ultimately produces palladium hydrogen covalent bond. Now the electronegativity difference between palladium and hydrogen is very less. That's why often these hydride is called as covalent hydride or non-polar hydride. Both covalent hydride, non-polar hydride. But if you look at this carbon, it is actually delta positive. So this carbon center is actually a polar carbon center. So that's why non-polar hydride or covalent hydride is not a good. Ionic hydride is needed. And among actually, so option A gone, option D gone. So who is remaining? Sodium borohydride versus lithium borohydride. Since the lithium aluminum hydride, the aluminum hydrogen bond is more polar than boron hydrogen in sodium borohydride. So option C is the best choice, or it results in maximum reactivity for reduction of ester to alcohol. And remember, this lithium aluminum hydride is a very reactive reagent, so it does. And by the way, whenever you use this lithium aluminum hydride for the first step, in second step dilute acidic workup or H3O plus is essential in order to get the product finally. So this is the overall discussion. I believe this video may be useful. So if you really enjoyed my content, please help this channel to grow. Thank you all. See you in my next video. Bye bye.